What's up guys, this is Steven and we're here to live, learn mathematics. I want to welcome you to our first concept video on algebra where we'll be going over algebraic foundations and solving equations. Specifically, we're going to be getting into expressions, how to evaluate them, linear expressions, and solving multi-step equations. So what is algebra other than a pain to take both in high school and college? Algebra is simply the branch of mathematics in which letters and symbols represent numbers and equations. It's these letters and symbols that got people all mixed up when they do it. So I'm here to clear it out a little bit. Alright guys, I want you to think of algebra as the study of puzzles. Study of puzzles. In every puzzle, you have to rearrange the pieces before you can see the big picture. An equation is like a puzzle, and the solution is the big picture to that puzzle. Before we solve the puzzle and see the big picture, we're going to talk about the pieces of the puzzle called expressions. Expressions are algebraic phrases containing ordinary numbers combined with variables using different operators. Operators being addition, subtraction, multiplication, and division. So an expression basically replaces plain English using one or two variables. So now we're going to do some examples. We're going to translate phrases into expressions, algebraic expressions. So number one, 3 times some number plus 8. Well, whenever you're looking at sentences with the word or phrase some number in it, you're going to start there. So I'm going to underline that. I'm going to go ahead and underline some number. Whatever you do to change this into an algebraic expression, you're going to start with the phrase some number. So what's happening with that number? We're 3 times some number. So we're going to do 3 times a variable, call it x. So we have 3x. Okay, so we got 3 times some number plus 8. So that tells us we're adding 8 plus 8. So 3 times some number plus 8 is 3x plus 8. Let's do the second one. 6 less than 4 times some number. We're going to underline some number again. Let's start there. Some number, we're going to call it x. 4 times some number. So we're going to start off with 4x. Now, it's 6 less than 4 times some number. So we're going to subtract 6. And we have 4x minus 6. And the last one, 8 more than some number. It's a little easier than the first two, but it's getting our practice in. 8 more than some number. Underline some number again. Call it x. 8 more than some number, we're adding 8. So we have x plus 8. Okay, so now we're going to go over combining and evaluating expressions using 2 examples. We got 3x plus 7 minus 6x minus 4. So in doing this, we have to combine like terms. What I mean by combine like terms is take everything with an x and combine them using any operation that you're given. So we got 3x minus 6. They both got x's in them, so I'm going to combine them first. We got 3x minus 6x. We got 2 numbers with no variables next to them. We have 7 minus 4. So I'm going to tack on plus 7 minus 4. So 3x minus 6x is negative 3x. We got 7 minus 4. 7 minus 4 is 3. The number's still positive, so we're going to put plus 3. Now, we're going to evaluate this expression when x equals 4. So say x equals 4. We're going to put 4 in for x. We're going to substitute x for 4. Think of x as a placeholder. We're just plugging it in. Negative 3 times 4 plus 3. Negative 3 times 4 is negative 12. Plus 3 is negative 9. We got negative 9. Okay, so now For the second one, we have 2 times, in parentheses, 9x plus 5 minus 3x on the outside. So first, we're going to have to distribute before we combine like terms. We're going to do 2 times 9x and 2 times 5. 2 times 9x is 18x. 2 times 5 is 10. So we got 18x plus 10. Now, on the outside we have a minus 3x. So we're going to keep that. Minus 3x. Now we can go back to combining like terms. 18x minus 3x is 15x. Plus 10. Okay, so now we're going to evaluate this expression again, given, let's do 3 this time. When x equals 3. So we got 15 times 3 plus 10. 15 times 3 is 45, plus 10 is 55. So when x equals 3, this expression equals 55, and we've evaluated the expression. Alright guys, now we're going to talk about linear expressions. Linear expressions describe the characteristics of a line on a graph, including the slope and the y-intercept. Okay, so now the slope describes the steepness of a line on a graph using this formula right here and given 2 points on a graph, x1, y1 and x2, y2. So using this formula we can find the slope, which is typically represented with m. So we have y2 minus y1 over x2 minus x1. Okay, so let's say we have 2 points. 1, 2. 1, 2. And let's make the second point, 5, 7. 5, 7. So you can think of these 2 points as these 2 points on this line. So we're going to use our slope formula. y2 is 7. 7 minus y1 is 2 over x2 is 5 and x1 is 1. So we have 5 minus 1. So 7 minus 2 is 5 and 5 minus 1 is 4. So our slope is 5 over 4. Okay, so now to find the y-intercept given a line on the graph, you're going to look to see where the graph touches the y-axis. You can find a y-intercept given an expression by plugging 0 in for x. So if our expression were, let's make it, alright, we got 2x plus 3. Okay, so say this is our linear expression. To find the y-intercept, where the line touches the y-axis, we're going to plug in 0 for x. So we have 2 times 0 plus 3. 2 times 0 is 0, plus 3 is 3. So our y-intercept occurs at the point 0, 3. Okay, so next I want to go over 2 different forms you'll find linear expressions in. So we have slope-intercept form, and slope-intercept describes exactly how you would find a linear expression. You have the slope next to x, so you have mx plus b. B signifies the y-intercept. So whenever you have a line in this form, you can easily find the slope and the y-intercept. The next form you'll find lines in typically is point-slope form. And you have your slope here again, m, and you have a point. You have the point x1 and y1. So given these 2 points and the slope that we found given the slope formula, we're going to write the line connecting these 2 points in slope-intercept form and point-slope form. So right here we have the slope. The slope is 5 over 4. So we're going to write y equals 5 over 4, which is the slope, x plus b. Okay, so now to find b, we're going to have to plug in one of those 2 points to then solve for b. So let's choose the first point, 1, 2. 2 is y. We have 2 equals 5 over 4. X will make 1 plus b. Okay, so now we have to solve for b, which is kind of getting ahead of myself because solving equations is the next video, but I'm going to get into it here. We are going to rearrange this equation to get b by itself. B in this case is our big picture. So we have 5 over 4 times 1, which is just 5 over 4. We're going to have to move the 5 over 4 to the left side of the equation to then find b. So what we're going to do is subtract 5 over 4 on both sides. We got 5 over 4 minus 5 over 4 minus 5 over 4 on this side. And what that does is cancels it off of the right side. So we have 5 over 4 minus 5 over 4. It's gone. Now to solve for b, we're going to do 2 minus 5 over 4. We got 2 over 1 minus 5 over 4. So they have a common denominator of 4. Let's give it a common denominator of 4. 1 goes into 4 4 times. 4 times 2 is 8. 4 goes into 4 once. 1 times 5 is 1. Okay, so now you have 8 minus 5, 3. So our y-intercept is 3 over 4. So now we have the equation y equals 5 over 4 x plus 3 over 4. This is slope-intercept form. Now we're going to find the point-slope form using one of these points and the slope. So we have the slope, and we have one of 2 points to use. Let's use 5, 7 this time. Okay, so we got y minus y1. We said we're going to use 5, 7, the point 5, 7. So y1 is 7. All right, y minus y1. So let's use the same point. Let's use the same point 1, 2. So y1 in this case is 2 equals m, the slope, 5 over 4, times x minus x1, which is 1. Okay, so we got y minus 2 equals, we're going to distribute 5 over 4 into x and minus 1. So 5 over 4x is 5 over 4x. 5 over 4 times 1 is 5 over 4. Okay, and if we wanted to, we can rearrange this equation to get the same thing we got over here for the point-slope form. Excuse me, slope-intercept form. So what I'm going to do is add 2 onto both sides to cancel it off to the left side. So I'm going to do plus 2 and plus 2. Negative 2 plus 2, that cancels out. It's 0 now. And we have negative 5 over 4 plus 2. I'm going to do that over here. Plus 2. Okay, I'm going to give it a common denominator of 4 again. 4 goes into 4 once. 1 times negative 5 is negative 5. 1 goes into 4 4 times. 4 times 2 is 8. Negative 5 plus 8 is 3. So we have 3 over 4, and we get y equals 5 over 4x plus 3 over 4. And that's exactly what we got up here for point-slope form. Alright guys, next we're going to do another example using the same type of slope-intercept form and point-slope form. So we're going to find the equation of the line passing through these 2 points, 3, 5 and 4, 7. So like I said before, we first have to find the slope. So because we're given these 2 points, we can use the slope formula. M equals y2 minus y1 over x2 minus x1. And again, because we have 2 points, we have x1 as one point and x2 as y2 as the other point. So let's see, y2 in this case would be 7. So we got 7 minus y1 is 5. And we got x2 is 4 minus 3. So 7 minus 5 is 2. And 4 minus 3 is 1. So our slope is 2. So m equals 2. So I'm going to set up point slope form right here. Y equals mx plus b. So we found m. Now we have to find b. So let's see. Let's plug in what we already have. M is 2. So we got 2x plus b. Now to find b, we have to use one of the 2 points that we were given. Let's use the first one. Let's use 3, 5. So 5 is y. 5 equals 2x plus b. Since we're using this first point, x equals 3. So we have 2 times 3 plus b, which gives us 5 equals 2 times 3 is 6 plus b. Okay, so now to get b by itself, we have to subtract 6 on both sides. I'll do that up here. Minus 6 minus 6. 5 minus 6 is negative 1. 6 minus 6 is 0. So we get that b equals negative 1. So our equation of the line would be, let me erase some of this work. So the equation of the line would be y equals 2x minus 1. Okay, now it's time for the big picture. We're going to solve equations now. We touched on it a little bit with linear expressions and linear equations, but now I'm going to go over it in more detail. There are two types of equations to solve: one-step equations and multi-step equations. I'll be doing examples for both. Okay, so we have two examples. Solve for x in x plus 3 equals 7 and 5x plus 7 equals 2. Now I know I've been using equation and expression interchangeably. The only difference between an equation and an expression is the equal sign. Typically when you find x plus 3 by itself, x plus 3 by itself is the expression. You add the equal sign and it becomes an equation. That's the only difference. This is what you would call a one-step equation to solve, and this is what you call a multi-step. We're going to get into that as I do it right now. So, how to solve an equation. You have to get x by itself. The big picture, you can only see the big picture when you isolate x. So, what we're going to do is do the reverse operation to get x by itself. So, for example, x is being added to 3. So we're going to subtract 3 on both sides. So I'm going to minus 3 and minus 3. So you got 3 minus 3 is 0. This cancels out. 7 minus 3 is 4. So x equals 4. And that's what you call a one-step equation because we've only done one operation to get x by itself. Okay, for the second one, we first subtract 7 on both sides. We're trying to isolate 5x. So I'm going to do minus 7 minus 7. 7 minus 5 cancels out. Or excuse me, 7 minus 7 cancels out. 2 minus 7, negative 5. So you got 5x equals negative 5. The next step to get x by itself would be to multiply by 1/5 on both sides. In other words, we're multiplying by the reciprocal of 5. So 1 times 5 is 5. 5 divided by 5 is 1. So this cancels out. The 5 is canceled out. So you have x equals negative 5 times 1 is negative 5. Negative 5 over 5 is negative 1. So you get that x equals negative 1. You could also just divide by 5 on both sides. I know some people are comfortable with hearing multiply by the reciprocal, but you could also just divide by 5 on both sides. So that would look like 5x equals negative 5. Divide by 5 here, divide by 5 there. 5 over 5 cancels out. X equals negative 5 over 5 is negative 1. And you get the same thing. Alright guys, if you found this video helpful, please like and subscribe. If you have any questions or suggestions on topics you want to see me do, please put it in the comments. Just a heads up, I'm going to be doing a live session, live lightning round, every Sunday, 6 p.m. to 7 p.m. If you have any questions, please join me at 6 p.m. Sunday.